every element of the list has the same type. And that type will be either that, it could be something else, but it's statically known. It's declared when the array variable is declared, or the pointer variable is declared. And you can access elements of an array using a dynamic index where array elements are numbered from 0 to n-1. Now that definition actually shows up on the next slide, 2 slides later. But yes, it doesn't matter whether the array is statically allocated or dynamically allocated. It is contiguous and you can access it with an index. And we can always determine the size of the array, as we did last time, the address of an array, element. By taking the base plus the index, size, and that, in order to ensure that that calculation will work, that requires that the array be allocated contiguous. Right? Otherwise, it wouldn't be the case. And the offset was just index times size. On the other hand, yeah.
How does it know it's running to an int and not a char or a long or
Yeah.
a double?
So I'm going to come to this in a little more detail in that next slide. So there's a difference between the typing systems. Maybe I'll just say that. The short answer is it doesn't know. Okay. But we'll come a little bit more on that in just a second. But let's get back to this, unless there's another question. So because the compiler doesn't know the address of this, it has to do something a little bit different when it generates code to access elements of a dynamic array. Everything is the same, except there's an extra memory read that's required right at the bottom to get the base address of the array. So looking at the third line, we see, which is the same in both, we see we put the address of B, the variable B, into R2. Now, in the case of the static array, that was the address of the array. Here it's not. It's the address of a variable that stores the address of the array. And so this extra line is needed, the fourth line, which goes to memory and reads this number. And then in the final line, you use that number as the base address, R3. Does this make sense? So here's the slide that compares different things about arrays in Java. And see, first of all, I said this last time, pointers are just references. So in C, almost everything, every variable is a reference. Every time you say class, app in Java, well, that's the variable app that points to an object. So almost everything in Java is a reference. The exception are the built-in types int, long, byte, short. Those, so if you say int I, just like in C, that variable I stores the value of the integer. In C, any variable could be a pointer, same thing, reference. So I can have int I can also have int star I, which would look like that. Everybody see that? And you'll notice that there's kind of something funny there is that I just drew the picture of a pointer to an integer. And it's declared exactly the same as a pointer to an array of integers. And in C, there's actually no difference. So if you have a pointer to an integer, it's just like having a pointer to an array of one integer. We'll talk a little bit about these things in just a second. So the way in C that we get a reference, a pointer, is with the star, so you put a star anywhere you want. We talked about the difference already between new and malloc, so that's that point. Now we're going to come to types. So C is weakly typed. In fact, C++ is more strongly typed, but it's still not as strongly typed as Java. So what is the importance of a type in a language? What does type do?
It tells the language how to interpret data.
Sort of, yeah. It tells a language how to interpret data.
It's like a preventative safety measure too.
Right.
So if it doesn't match the type, then it'll warn you.
It tells the compiler what operations are legal on variables. And in a statically typed, well, it states what operations are legal on variables. In a statically typed language, it tells the compiler. And C is a statically typed language, which is very weakly typed. And so in C does have this property that once you declared a variable to be a pointer to something, then when you dereference the variable, like for example, when you access an element of the array, the C compiler knows it's an integer, and if you try to use it in a context where integers are not allowed, you will get an error. But I can change the value, the type of B in C in a very simple way. I can just say, so you asked about array of char, right? So let's just say I have this. Okay, so that's an array where every element is a single byte. And so when acts the code, the compiler generates to access that array, instead of multiplying the index by 4, it multiplies by 1. So it's different code the compiler would generate if it has this or this. And see, I can do this. I can have C, so here's C, and D both point to the same array, even though they're different types. Right, now, you have to have a typecast here. We'll talk later about why malloc you don't need a typecast. It is a special type called void star. I'll save that lovely bit of stuff for later. But because of the fact that all pointers are the same size, this assignment is perfectly fine to do. And it can lead to very odd sort of things happening. Here, if I access elements like C3, that's going to be right in the middle. It's going to be the third byte of an integer here. So the type system is weaker, and that's kind of all I wanted to say. We'll get into more details about types. The thing I want to spend some time on is bounds checking. So this turns out to be a really important issue for programming. So what does bounds checking mean? It means that if you do have a language that checks bounds, a program that attempts to access an array element that is either before the beginning or after the end of the array will be prevented. You'll get an error. So for example, if I have an array of 10 things statically allocated here, or if I malloc something here that's 40 bytes long, and I try to access either B sub -1 or B sub 10, that should be an error, right? What would happen in Java? So you can say that in Java, an array of 10 things, and I can try to do this in Java. What would happen in Java if I did that? Exception? What exception will be thrown? Array index out of bounds. So we're going to talk now about how that works. How is it that in Java you get array index out of bounds? And to get at that, what I want you to do is think about, so we're going to look in C now. And here's the procedure in C that zeroes out an array. The parameters are an array, so in star A, right? right? A is an array, and n, which is the number of elements of the array, and then we have a loop that copies 0 into each element of the array. Now, the question is, what would happen if when you call I0, I call it on, so I'm going to just do this. I'm going to just have it int b 10, and then I say I0 b, what happens? And that was rhetorical. Here's the question I want you to discuss, is that we would like, perhaps, to get an error. And the question here is, could you generate that error statically? Can the compiler know that you have an out-of-bounds situation and give you the error in the compiler? So that's what I want you to discuss with each other. Can array bounds checking be done statically?
What do you see?
All the bits that take up the array and first starts allocating arrays. No?
I don't know, somehow, maybe it works, but it doesn't throw any exception. It just returns some.
You would ever
Yeah, pretty numbers.
All right, so let's have a vote here. Who thinks that it can be done statically? Raise your hand. Be proud. Stand up here. Totally excellent. Maybe, possibly. I'm seeing a lot of hands starting to come up. It's like, maybe, I'm not really sure. What's he getting at? Okay, so who thinks it cannot be done statically? That doesn't mean no one knows what's going on. It means half of the people know what's going on. Or like 10% or something. Who's not sure? Okay, these are all really good answers. Yeah, no, you can't. Can't do it static. Why not? Yeah, so one part of this is that if I created the array dynamically, I just said 40 bytes. And I didn't say this, but it turns out that Malloc didn't actually know what the hell you were creating. It didn't know it was an array. And nowhere is it ever written down anywhere that that's actually 10 integers. It's just 40 bytes. Now that's actually something that we could fix in C. And in fact, the allocator itself actually secretly knows how big this is. But that's not available to the compiler. So that was just kind of a decision that was made in C. So in C, you cannot determine in any way at all ever the size of a dynamic array. If you want to know the size, you better remember it. Store it in a variable or something like that, right? It's up to the programmer to do that. But that actually, as I said, something you could fix. Arrays in Java are actually two things. They're a pointer and a size. It's, the length of the array. But that, even if we fix that, we still can't do it. Why is that?
They don't have to sort of run the function during compile time.
Why? That's right. You have to run the function. Why?
Without
Why? What is it that I need to know for this piece of code to know whether that code might overflow the array? One thing I need to know, which we've discussed, is the size of the array, which we don't know. But let's say we could know that. What's the other thing you need to know?
I assume how much you're trying to access, so n.
Yeah, the value of n. Right, because this loop is going to go through 0, 1, 2, 3, 4, all the way up to n minus 1. N is a variable. Are the values of variables static or dynamic? Dynamic. The compiler does not know when it generates this code what n's going to be. In fact, that procedure will be called with the same exact code with many different n's and many different arrays. So it also doesn't know. It might know the value. You might be able to figure out for a particular array how big it is. But this procedure can operate on many different arrays. So how, and this is true in Java, it's true in every programming language that has arrays, I'm going to say. So how is it in Java that we get an exception? Well, first of all, the fact that we got an exception tells you it's dynamic, right? Because if it was static, you would get a little red line and tell it. That's how static errors is important, right? The compiler tells you. And this is what, as we get back to the beginning of class, what you want. You would like every single error to be a static error. My code doesn't compile, and when it finally did compile, it just worked. This would be a great place to be. And there's a language where that's true. It's called Prolog. But that's a side point. So how does Java do this? How do you think? Dynamically checks, yeah. So in Java, in every programming language that has array bounds checking before every array access in general, there's an if statement. And it says if, so right before the a sub I equals 0, it says if I is less than 0 or I is greater than the size of the array, minus 1, throw new array bounds exception. Okay? That, now in this case, it can optimize that and it can move the check outside the loop. But in general, every array access has an if statement before it that's inserted by the compiler. Now, what do you think they did in C and why? Well, first of all, we know the C compiler can't determine in any way, it can't generate code to find out the size of the array. But even if it could, C does not do array bounds checking. Why not?
Well, it's like an efficiency because it's something like the programmer to program that in itself to do that needed.
Precisely. So, for the sake of efficiency, so in the days that, how old do you think C is? What's older, me or C? C. Me. I'm older than C. When was C developed? Why? Was it, yeah, why? Who knows?
It was like one of the first high-level languages.
No, it wasn't one of the first high-level languages. And many people would dispute whether C is actually a high-level language, but that's a different point. It was developed, yes?
It was developed at Bell Labs because
Yes.
everyone was using different programming languages.
Why was it developed at Bell Labs? For a very specific reason. To write Unix. So it was developed to write an operating system. They actually started with A. Right? And A is the assembler. Right? So they started, and this was, they didn't really start with assembler, but let's just say they did. At some point, people wrote operating systems in assembly code, and you're not gonna have to write big programs in assembly, but it's bad. So for a long time, they used B, which there's different kinds of, these are macro assembly-like languages. One's called Bliss. And the guys at Bell Labs, they actually, there's a long story behind this, but there was an operating system they worked on called Multex with. It was a joint effort between GE, MIT, and Bell and AT&T. Bell Labs at that time. And it was a complete disaster. And these guys left. And they said, we're going back to the basement, and we're gonna do the exact opposite of everything that was done in Multex. And and so they came up with the name Unix as a term, and I'll let you figure out. They were spelled differently. They changed the spelling to politically correct later. And they developed this language for writing the operating system. And so for them, given the context of the time they were in and also the purpose of the language, they cared a lot about extra code might slow things down. Now, array bounds checks today, with how fast computers are, they're just nothing. It's dumb to not have them, they cost nothing. But at that time, the cost was meaningful. And there's a philosophy in C, and the philosophy is, don't add any extra code that isn't needed for correctness. Assume that the programmer knows what they're doing. So as you said, hey, if the programmer thinks they might have an array out of bounds, let the programmer write a statement that checks. So you can add array bounds checking. It's just an if statement if you would like to. So there's a joke about this. And here's the joke. Let's see if you can find it funny. Is that people say that C gives you flexibility. This is flexibility. So this is sort of normal. It's composite flexibility. But it's a bit like having the flexibility to drive to steer both front wheels of your car independently. So sometimes useful, but quite dangerous. And as it turns out, as somebody pointed out here, this decision to not have array bounds checking C created the biggest vector for virus attacks that is still being exploited today, and that we're going to talk about later in the course. So it turned out to be a huge mistake. And it has never been fixed. And it actually can't be fixed because lots of people have written code that doesn't do array overflows, even if but correctly. So there's no array bounds checking in C, which means that if you do this, or you do this, it's just going to work. But what it'll do is it's going to write into memory here, there's b sub -1, or here there's b sub 10. So you can see now this error actually lets you write values anywhere, which is what virus letters quite like.
Well, you say that somehow this might be useful to be able to know.
Yeah, this is how viruses work. It's like one of the biggest open gaps. Every interesting program has an array overflow bug somewhere in it. And if that exists in a program, a clever virus writer can attack and take over the program. And we're actually going to do that in the second half. Of course, not second half, before the break. What's that? So you can decide whether you think that's a benefit or not a benefit. Okay, so just to sum up on static and dynamic arrays, I'm going to talk for a minute or two with each other, see if you can come up with one. We have a choice. We have both in C. Now in Java, there are no static arrays. All arrays are dynamic. So I'd like you to list one benefit of static arrays and one benefit of dynamic arrays. Okay, so what's the benefit of static arrays? What's one way that a static array is better than a dynamic array? Yes, so it's more efficient to access, it's faster to access static arrays. And actually, going back to the story of the 1980s, there was a time where that was actually very, very important. It's a little bit less important today, But still remember that memory access today is still slow compared to CPU access. Now it's much faster compared to memory access. How long ago was it? 30 years ago? 30?
40.
40.
2020.
40 years. Oh, let's let that sink in. 40 years, that's a long time. Okay, so that's the main benefit of static arrays. So if you know how big the array is statically, use it, it'll be faster. All right. What's one benefit of dynamic arrays?
Scalability. Like,
What do you mean by scalability?
Like you need to keep changing the size of the array. Say you have like a customer database and constantly keep getting new customers. You gotta keep updating.
Right. So you're 100% correct. That's exactly what I would say too. Just want to be careful about one thing. I don't know you didn't mean this, but let's be careful about this. It's just because it's a dynamic array does not mean I can change the size of an array after I made it. So the size of arrays are determined dynamically, but once you set malloc, that array size cannot change. If you want an array of different size, you have to make a new one. But as you point out with a dynamic array, the size of the array can be determined based upon, for example, inputs to the program. So if we were going to use a static array for some program that we wrote that maintained in an array information about students, if it was a static array, I'd have to decide statically, like me, the programmer, when I wrote the code, how big that array should be. And so I might, for example, say, well, what's the biggest possible class we could ever have? And if I was writing that code 10 years ago, I might Google different things, look at universities, I don't know, maybe I come up with 500. And I say, well, I'll double it, 1,000. Compile the program, distribute the executable. And then, I've heard of the term MOOC. Okay? So this massive online, open online classroom. These are these online things where a class starts day 1, there's 100,000 students. And by day 6, there's 12 or 13. There was a time when MOOCs were very popular. They're still sort of popular, but not as popular. My program would break, right? Because 10,000 or whatever the size is bigger than 1,000. So with things that are statically sized, you have to anticipate the bounds of the size. I actually have waste memory. A lot of classes are really small. And I have an artificial limit, right? So actually, most of the time, you're going to use dynamic arrays because you want to be able to size the array without making assumptions on the input. If it's based upon the input. If it is truly based upon a static thing, like you have a list of, static strings or something, and then you can use a static array. Questions on that? Okay.
Does that mean that implementations with like .add and stuff like that?
Oh, right, yeah, so we can come back to array lists. Remember I said array list is implemented with arrays. And this is the one difference between an array list and an array. The reason you don't use an array, well, there's two differences actually. One is that if I just use int, little I int, I don't have objects, but I can use big I int as an object, so like that this way. But the main difference is that you can change the size of an array list. Array list sizes are not bounded, you just add things to them. How does that work? How do you think it works?
You just copy the elements.
Yeah, so we're actually going to do this later in we have an assignment where we're going to have a resizable list. And there's actually two ways to do this, depending on whether you want to optimize for access time or add time. If you want to make adds fast, then what you can do is make an array list more like a linked list. But if you don't care about adds being slow, but you want access to be fast, which is what array list does, is that when you you'll initially say, allocate a list of, say, 16 things. And once you try to put the 17th thing in, the array list implementation makes a new array of 32 things, let's say, copies the first 16 into it, and now you can add up to 32. And then you get to 33, it'll do it again. And make 64. And here, if I'm increasing the size exponentially, I'm not going to pay that cost of copying very many times. And then when I access, it's just like an array. And that's the implementation that you'll see in an assignment. Other questions? And of course, that you can write that code if you need to have a resizable order. Okay, so here is just showing this for a specific reason here to help you understand what we mean when we look at, in this class, assembly code that contains dynamic things. So this, on the left is the static array. It's just like the b colon. You say b colon dot long 0 dot long 0 dot long 0 dot. That's the array. Look over here. Here's the dynamic array. And you say b colon dot long. That's it. It's not the array. But then you're going to see b data colon dot long 0 dot long 0 dot long. That's meant to be what's allocated dynamically. But we don't have a malloc right now in assembly language. And so we're going to give you a assembly file that's as if it was a snapshot of the execution of this program after the call to malloc. And so what you'll see is that in the simulator, that b colon dot long will say b data. And so this is at 3,000. There'll already be a 3,000 there. And the point of this little purple box is so don't get confused that that's static. You don't actually know, when the assembly code was generated, you're not allowed to know that the array is at b data because that's a dynamically computed value. And that's the reason why, if you look at the code, and the fourth line down, which is the bold on the right-hand side, that's that extra load that loads the value of b, which is b data, but you're not allowed to reference. Does that make sense? Really what we should do is like have that be 0, and then we have some code before this that runs that calls malloc. Just trying to keep it simple, but by doing that, we don't want to confuse. Alright, so we'll just start talking about pointers in C. So you've already seen it, right? Because a pointer is a dynamic array. So let's just erase this business here. So I'm going to change the name of that one so I can talk about both of them together. So I'll just call that C, B and C.